Okay, so again, we can't use the blue idea. This is not valid because we do not have an x value that is growing forever. So we go straight to the green idea, factor and divide. So I'm going to start on the bottom because it's easier to factor the bottom than the top. So the bottom will factor into x, subtract 4, multiplied by x plus 4. We want to talk about that. If you feel like you struggled with factoring or you can't remember, don't stress about it. We can just review as we go. It's not really, factoring for this class isn't really very hard. Here's a key thing. It says right here that we should factor and divide. That means if we can't find matching factors on the top and the bottom, it's not really going to help. So the expectation is that one of the factors in the numerator will likely be either an x minus 4 or x plus 4, because otherwise it would not have been useful to factor. So I'm going to hope for that. I start here, 24. That's 6 times 4. No, there's an x here and there's an x here. All I have to do now is figure out the plus and the minus. What I do to figure that out is I can do it in my head, but just so you can see how I'm thinking, I've got x times x, so we just write this off to the side. This is just my scratch word. Then I'd have 6x, then 4x, then 24. I need this to be negative, and then I need these two to add together and give me a negative 2x. So that means I need a negative here and a positive here. Question? Please, Blake.
Sorry if I'm getting a little bit ahead, but
You're good.
You cancel the x plus 4 since it's 2 terms.
2 points for Blake. So I'll do my best to be sarcastic, although I'm not very good at being sarcastic. So Lindsay Worthen was kind enough to make this nice sign for me because she learned very quickly that I consider cancel to be a foul word, and I don't say that word in my classroom, otherwise it causes me great sadness and anxiety. Yeah, don't cancel, it causes problems, but we can do what you're thinking, which is we can say, okay, let's move this out of the way. So we have some room. And we can create a better version of that limit problem. So make sure you write equal, limit, x approaching negative 4. And we can say what we really have here is x minus 6 divided by x minus 4. And all of that is being multiplied by x plus 4, 2 for Blake, but I didn't give you 2 before Blake. Like that. It's better to not cross it off, I promise. Question for the room. This is how you vote. This means true.
Would that be equal to 1?
Hold on a
So
second.
x plus 1 plus x.
Let's pause for a moment. 2 points still for asking. This means true, this means false. I want you to vote. This box right here, go back to the one we worked on a second ago. Mathematically, I need you to tell me, is this formula here so this formula is this, so this purple formula is the same as this blue formula. True or false? Show me your hands. So this purple formula is perfectly identical to this blue formula. True or false? You have to vote something.
What's true?
True is a 1, false is a 0. Can't get it to go blue, sorry. There we go. So the purple formula is the same as the blue formula. True, false. Show me your vote. Everyone gets 2 points for voting. The correct answer is false. Okay? The correct answer is false. The only reason, what we are saying is we're saying that this limit statement is equal to this limit statement. We're not saying the formulas are equal. The only reason the limit statements are equal is because we have an x that is growing forever, so it's legal to do the comparison to create a easier to use formula. Any questions about that? Okay, now go to this one, number 4. And prepare to answer this question again. Is this orange formula, I should say this orange formula is equivalent to this yellow formula? Show me true or false. That was better. If you're doing this, give yourself this.
Okay.
We didn't do the comparison, we just factored. So the orange and the yellow are exactly the same. They're exactly the same formula. But here's where we have to be careful. If this formula has a name and we call it f of x, raise your hand please if you can answer this question. For this formula f, what would you tell me f of -4 must equal? Like what would go inside this orange box? Hands up. If you're trying to answer the question by looking at this orange box, you're making it way too hard. You want to answer the question by looking at the yellow box. This is going to happen all year long because the orange and the yellow are equivalent, but it's a lot easier to see what's going on by looking at the yellow. So what goes inside the orange box? In your head? Fair amount of uncertainty in the room. Let's go, Xander.
-6.
Say again.
-6.
2 points. No. Other votes? Let's go, Ellie.
Is it 5 over 4?
2 points, but no. It's okay. Other. Let's go, Ella. James.
-5.
2 points, but no. This is really good. Let's keep giving away points. Let's go, Sam.
Is it undefined because of the x plus 4?
This is why I hate this word. Okay? If you plug in -4, this becomes 0. This also becomes 0. 0 divided by 0 is undefined. Undefined multiplied by anything else is still undefined because we don't know what undefined is. So that's why I'll just gently and persuasively tell you, let's don't use any foul language and the word that shall not be uttered. So feels like Harry Potter. Okay,
It cancels out to 1 in every.
I don't say that, but
I didn't mean to say that.
making me feel
I'm
bad,
sorry.
Aspen.
I didn't mean to say that. I'm
You're
saying it equals 1 in every situation except for -4.
Perfect. Perfect.
Oh, it's like what? I forgot about that.
It's okay. Everyone does. I do too sometimes. Does that make sense?
Yeah.
Yeah. So this, for this situation, it becomes important that we didn't cross it off. So this is undefined. 2 more for Aspen. We want to talk. Aspen summarized it really well. We want to talk about it more. Okay, so now go back over here. Look.
Yeah.
We're. Oh yeah, please. HT. My bad. Will.
Wouldn't that be a hole?
Well, kind of.
For a previous class, they would have referred to it as a hole. On the AP test, they referred to it as a removable discontinuity. So I just have to get you used to the word. So,
Yeah.
2 more.
Let's go. Yeah, also.
It certainly would have been easier to talk about if they just continued to call it a hole.
Yeah, honestly. I think in this one, it actually would have been easier to use the top because -4 squared is 16 minus 16 is 0.
It's fair when you're finding this that using the top goes pretty slick. What we've got to do, 2 more for HT, we've got to figure out what's happening when x is almost -4. And using the orange formula, it's impossible to do that. So here I can see it because, now go back to Aspen's comment. If x is close to -4, Aspen, what's this going to equal? points. Let's try somebody else. If x is close to -4, if x is, there we go. Yeah, you said it earlier. If x is exactly -4, this is undefined. If x is almost -4 or anything else, this is 1.
So the answer would be 5 points.
Right, so now we're back to Ella's comment, that if you think of this as being 1, which it is when x is almost -4, then we just have, do a little scratch work here. We have, let's see, close to -4,
Me too.
-6 over close to -4, -4. We definitely get -10 over 8, also negative, sorry, which is a positive 5/4. So that is the value of the limit. Which means, hey, don't lose track of the big picture. Like, don't get stuck in doing the steps and you forget what things mean. The AP Calculus test is not about doing a lot of computations. It's about understanding what they mean. So, can somebody tell me what it means to say that this limit has a value of -5/4? What does that mean? HT.
As x approaches -4, y approaches 5/4.
Perfect. Perfect. And then HT, like you noticed earlier, if x is exactly -4, we don't have a point. So if we were trying to draw a graph, I'll give 3 for that one. That was well said. We're over here at x equal -4. My scale's not accurate, so don't worry about it. Right at x equal -4, there is no point on the graph. But near x equal -4, there are 2 points. That's why we have a removable discontinuity at that spot. So, questions? Cool. We've done the first part of the problem. We need to do the second part, which is we need to focus on determining if there's a horizontal asymptote or not. Let's get a vote from the room. 2 options. We have to go figure out the limit as x approaches positive and negative infinity. We can do that using the orange, or we can do it using the yellow, because we already decided that they are equivalent. Those are the same formulas. Raise your hand, please. Which one would you like to use? Orange or yellow? Which would be a better choice? Hands up. Okay, everybody who raises their hand. Which one's a better choice? Just waiting a second. Searching my brain for names. Oh, hold on. Shoot. Oh, I lost it again. Torno, that's it. Cecily. Which one's better, Cecily?
Orange.
2 points. The yellow is actually easier. Well, to be fair, approaching infinity, either one works pretty good. We've already kind of simplified this one. Point if your hand was raised. So I prefer to go here. I wouldn't say it's necessarily wrong to go back here, but I think I can answer it quicker here. So I'm doing the limit. Oh, because this is why. Cecily, if x is getting infinitely positive or infinitely negative, what will this equal?
1.
That will be 1. So now all I have to do is this. For the second half of, can I erase the board? For the second half of the problem, I just need to go find the limit as x approaches infinity of x minus 6 divided by x minus 4. Like that. So if x is approaching infinity, when these 2 terms add, adding -6 is really going to make no difference. So raise your hand if you know what goes inside this box. Hands up. There we go. Let's go. What goes inside the box? There's somebody new. Let's go, Bella.
1.
So these 2 things add. So essentially we just have an x. Same thing on the bottom. So the top is growing exactly the same as the bottom. So we get up 1 right there. Show me your hands if you knew that. Point. 2 for Bella. So about a third of you that can't tell if you're just nervous or weren't sure, just want to raise your hand, or who wants to talk about it? Okay, cool. If you're ever nervous about talking in class, just come see me in the morning if I'm here at lunch or after school, and we just talk about it. So, Nadia, question?
So then, those two adds, you just added -6. How did we get the x again? I just got lost again.
Are you okay that from the previous word,
Yeah.
we were able to say, rather than find the limit of this as x approaches infinity, we can just find the limit of this?
Yeah.
Awesome. So then what I did in my head, I should have written out more too for Nadia Chiara. I should have said, really, we're going to do this step here. We're going to compare terms that are adding. So when x gets added to -6, as x grows forever, it doesn't really feel like we're adding anything, because x gets so much bigger than -6.
Yeah.
So I get a new limit problem that looks like this.
Oh, I get it now.
Better? Two
Yeah.
more. Please.
So you just completely ignored the 6 and 4.
I don't ignore them, but I logically conclude that if I'm going to let x, see, we have no concept, none of us have a really good concept of what it means for x to grow forever. Like, that's saying x could be a number that is 1 million digits in length. Like, that's, you just can't think of how large that is. Like, growing to infinity, like, we don't have a conception of that as human beings. We just cannot conceive what that really means. But if that happens, adding 6 to a number that's 1 million digits long doesn't make much difference. So, 2 for Lily. Appreciate the feedback. All feedback is appreciated. The worst thing in class is when everyone just stares at me like, feel like I'm Charlie Brown's teacher. Okay. All right. Other questions? We need to check as x goes to negative infinity as well, but the same result's going to occur because with power functions, the comparison doesn't change. So now we can write our answer, which is, as x approaches infinity, meaning as x gets very, very large, y gets close to 1. In fact, eventually y is almost exactly 1. Y will never actually be exactly 1, but it is extremely close. So this graph does have a horizontal asymptote, and that horizontal asymptote is at y equal 1. Make sure you write y equal. The grader won't give you credits if you just say horizontal asymptote of 1. Question? So it's very kind of Nadia to wear a shirt that color coordinates with the homework packet. So we'll ask someone to wear a nice bright yellow one to coordinate on Tuesday. So, okay. Questions? Awesome.